Oh yeah, this one. The idea of something called the confusion matrix. We're going to revisit this a lot. This is a metric that is used to evaluate the performance of a model. And although there's a large chapter, chapter 5 is all about model performance analytics. How can we decide if our model is performing well or not? And we devote a lot of time to that, and then we'll also see how we can improve the models and so on. But it's hard to avoid this, even though we're spending time on it later. It does show up in some of our earlier content. So this is actually related to the employee attrition, and you're going to see this in our project today, where a model designed to classify individuals in terms of whether or not they are going to leave the company can make some correct predictions and some incorrect predictions. Okay, so we're going to see the model telling us, all right, this is what was predicted by the model, right? Somebody is going to leave or not leave, right? So leave means a kite is leave, not a kite is they're going to stay. So we want to kind of look for where we have matchups, where the predicted attrition matches with the actual attrition. So we're going to be able to say, in this example, there were 66 cases where the model predicted that an employee was going to attrite, and they actually did. So this comes from taking our model and trying it on the data to see if this model that we've built is going to be effective in identifying those individuals who actually did leave the company and identifying those individuals who did not leave the company based on all the characteristics that go into the model. Yeah.
You normally look at the effectiveness of models after.
Yeah. 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 So we use the data to build the model. You've seen that there are two ways that the model is tested, right? You often reapply the model to the data that was used to build the model, the training data. And then we also apply the model to what's often called the holdout set or the testing data. And this is a way of seeing how the model is going to perform on data that wasn't used to build the model. And we'll also get into some discussion about what it means if the model does well with the data that was used to train and build the model compared to when the model doesn't do well on the testing data. So a model can do well on the training data and not as well on the testing data. When that scenario happens, we have to make modifications. We have to revisit our model and try to achieve a balance between those two. And that's also a later topic, but a pretty important one. So you are going to see this confusion matrix, just funny name, but you want to be looking out for, there are lots of different ways you can analyze it, right? And a lot of times this terminology is used where we have predictions for those who are not going to leave the company, and actual cases where people do not leave the company. There's 719 of those. Those would be called true negatives. It's often the case where whatever we're trying to predict could be defined as a positive outcome, even though it's the case of employee attrition. We wouldn't consider employees leaving the company to be a positive thing, but that's often defined as the positive case when that is the target we want to be focusing on. So if we are thinking about a scenario where we want to minimize people leaving the company, we may look at different parts of this table and decide which is the most important case to focus on, and which is the case that we want to minimize, right? And it could be really any of these things. Do you want to minimize the false positives or false negatives? And what do those things mean? So and this is still kind of a preview of what is to come, but there are some metrics that come up, and one of them is called recall. Recall is going to take our true positives, okay, so 66 cases where the model predicted someone was going to a trite and they actually did. And then that is divided by the total number of true positives, which is our 66, and then also divided by the number of false negatives. So what the recall is giving us is a measure of the percentage of correct predictions. So the model correctly predicts that employees will cite only 46% of the time. You might want to think about, is that good or bad? Probably not that good. So there may be some improvements that are necessary. So that's recall, and we will revisit this. There's another metric called precision, which takes the number of true positives and divides by the total number of true positives and false positives. So that's really looking at a percentage relative to the actual results. Yeah. So if we were to calculate the precision in the case of employee attrition, we are going to find that 76% of the employees that were predicted to attrite were actually did. So that seems like a pretty important metric to understand, right? And then finally, we have something called accuracy, which just takes the total number of correct predictions divided by the overall data, how many employees we have in our data set. So that's the total number of predictions, whether they are correct or incorrect. And then this is more of an aggregate metric to tell us, well, how well is the model performing overall? Like, how well does it do in predicting the outcome for an employee, whether or not they are going to leave the company? So that's accuracy. And finally, we have error rate. I forgot there was one more here. So the error rate is pretty much, you can see that it's actually the exact opposite of accuracy. So you can pretty much see, all right, well, if the accuracy is 89%, then the error rate must be 11%, and that can be calculated from the matrix. And that can be interpreted as 11% of the time the model incorrectly classifies the employees. So that is looking at ways to evaluate the model. And I'm going to leave it to you to think about what is going to be a more serious case in this scenario with predicting employee attrition, and then we can come back to that concept together.